Hello and welcome to this short video on Transparent Data Encryption, or TDE, on Fujitsu Enterprise Postgres and the OpenShift platform. This is one of several short videos that takes a look at some of the enterprise features that are available within the Fujitsu Enterprise Postgres product. So what's Transparent Data Encryption, also known as encryption at rest? Well, it's a security feature that's designed to protect your data when it's sitting on disk, even when the database is not up and running or not being used. So that's sort of why it's referred to as REST. So if a hacker gains access to your host machine that's hosting your database, or even gains physical access to the disk on which the data is stored, they're not going to be able to read it or make use of it. It's called transparent, or I guess the word transparent in the name is due to all this happens without there being an impact on the user. There's no noticeable impact in performance. He doesn't really know whether his data is being encrypted or not. So in this session, what I'm going to do is show you some of the settings that are enabled by default, so that when you deploy an FEP cluster in OpenShift, it's all set up and ready to go for transparent data encryption to work. And then what we'll do is actually look at how to configure an encrypted table space. So any data objects that we put into that encrypted table space will automatically get encrypted as they're written out to disk. And then what we might do is do a bit of a look at an example once we've created a encrypted table space, and we'll move it. We'll create a database on an unencrypted table space. We'll have a look at it and how we can see what that data looks like, and then we'll move that to our encrypted table space. And okay, let's get into it. So what we'll do first is actually deploy an FEP cluster using the Fujitsu Enterprise Postgres operator. So you see we don't have any clusters at the moment, so we'll simply click on Create FEP Cluster. And there's a few videos around to do that. We'll use the YAML, and we'll call this one FEP GWE1. And really we'll just leave this for this particular one with a default configuration settings. You'll notice that there's a TD passphrase setting in here. We'll talk about that in a little while. This will just create a single instance. So we'll fire that off. So our cluster's up and running now. If we just go into the terminal, maybe have a look at the processes that are running, we can see the processes we'd expect to see associated with a Postgres instance that's running. I'll do a DF, and you can sort of see some of the main mount points that are defined in the YAML file when we create the cluster, and we'll have a look at those in a bit more detail in another session as well. But you can see some of the key areas. There's this user data where the data files and the default table space are stored, along with some of the standard configuration files. PGWAL, where the transaction logs are kept, then our application or product logging files, and then there's this table spaces directory that we'll have a look later on. So when we create a TDE encrypted table space, that will get placed into there, and we'll actually be physically moving a database that's unencrypted from the default table space into this area as we encrypt that data on the disk. And then there's a couple of backup directories as well. So we'll go into that database directory. As you can see, that's where most things are hosted, and we'll have a quick look in user data. We'll talk about those later, but underneath here you can see there's some of those other configuration files that I talked about. And then under this base directory, this is where the data files. So you can see there's 4 directories listed there. Oops. 4 directories are listed there with these numbers, and these relate to the OID of the object ID of the database that they're associated with. So any objects like tables and that are created within that particular database will be stored within this folder. So if we actually connect to the database, and we list the database. You can see there's four databases there. Okay, let's load a schema and a data. I do have one for an airline database, but it's probably a bit big to upload through a client like dbeaver. So what we'll do is we'll duck across to here, into a terminal, and we can, this is an easy way of copying files up to our pod from the local machine. If we do get pods, to get the pod name, you can see there's a number with that's the one that's running our FEP instance. If we have multiple and we want to know which one is the master, we can use our FEP role equals master. So we're basically saying where the labels FEP role is set to master. And of course, because we've only got the one instance running, that's going to be this one. We can shell into it. And so we're now connected to that container, and we're going to put the, we'll upload the file to here. So we use OC sync to do that. I've got that, I think that's the directory locally. Oops, I'll need to put that in quotes. Yeah. So, okay, that's the file we want to upload. So OCR sync everything in the current directory up to FEP GWE 1 STS -0, and we'll put it in that database directory. Okay, it's a fairly large file, so it might take a little bit of time. Okay, so that's copied up. If we go back to here, we should now see, if we go into the database directory, we have the file there. So we'll just execute that. Into the airline. And we'll let that run. It's now copying data in there. Okay, so our database has been loaded up. Let's go and have a quick look at it. If we list the databases, we've now got this demo database that we've created. So if we connect to that, you can see we've got booking schema, with a number of tables in there. So let's have a look at so the flights table. And we've got some data in there. So what we'll do, what we'll do now is we'll go to the directory where this is going to be, which is this base directory, and you can see that we've got an additional file there, or sorry, an additional directory there that's been created. So if we go into there, I can see we've got a lot of directories, sorry, a lot of files, and these files represent a different table. The FSMs are free space map, and VMs are visibility maps. There's plenty of information out there on the use of those. Some of these files, when they reach a gig in size, they'll append it with a .1. I don't see any examples, or the data files are less than 1 gig there. What I might do again is just connect to the database. Oops. Should do tickets. So we can see that the tickets table has an object OID of 49329. So therefore we know that this file here is the table holding the data for that data. So if we edit that file, oops. You can actually see that you can make out a lot of data. So it's not really encrypted. We can see the values in there, and if someone were to steal this, then they could quite easily put the information together because of the way the files are structured, and work out what each of these tables were, and rebuild a pretty good representation of how the data relates to each other, and steal your data. So what we'll do next is we'll have a look at how we can encrypt all that using transparent data encryption. So what we might do before we go ahead and create the encrypted table spaces, we'll just connect to the database. And we'll run a query. So I'll just go to a query we've got for the this particular demo database. Okay, it works okay. So what we'll do is put timing on. So 238 milliseconds without encryption. Now what I'll do is we'll go through and we'll create a new table space. Now we know the directory where it's created is already there. There's a default one there that we can utilize, and that's called TB space 1. So we give it a name, TD table space, and then we specify our location. Oops. Which will be database table spaces, which is actually on a different volume as we looked at earlier, and there was that empty directory TB space 1 that we can use. And we can also specify here the encryption that we want to use, whether it's AES 256 or less. You know, there's no reason why you would use less really. So encryption algorithm. Hopefully I get this typed in without any mistakes in spelling. AES 256. And that creates our table space. So if we, I think it's actually what I'll just get everything back. So I can't remember the specific column names. And we join that with our PGX table spaces table, where the OID is equal to the PGX tables SPC table space. Oops. That was supposed to be a star to get everything back. And we can see we've got this TDE table space that's encrypted. So the next thing we want to do is move the whole demo database from the default table space where we had a look and we can read the data across to this new TDE table space that's encrypted. We do have a number of connections, so we need to disconnect from our demo database since that's the one we're going to move. So we'll connect to our Postgres database, and we've probably got some connections running, so we will pgstat activity. So any running sessions we can pick up the process from our pgstat activity table. Oops. Where pgstat activity and the dat name is equal to demo. And the PID is not equal to our PG backend PID. Okay, so now what we should be able to do is do an alter database demo table space. Sorry, set table space. I think it is TDE table space. So what we're saying is change the demo database we just created with the airline data in it to use that encrypted table space rather than the normal one. And that's going to take a little bit of time because it's going to move all the data from that file system across to another file system. So it has to actually physically move it across and encrypt it. But as you can see, it wasn't too bad. Oops, it's not going to work in there, is it? Actually, before we do that, no, so we'll quit out here. So we've actually moved it from our user data across, and you can see that it's a fairly reasonable sized database that now it's actually filled up that. So if we go to there, if we're in the right directory, where are we? And we'll go to table spaces. And we can see we've now actually got something in there, and that's our new database. So that's our database. If we connect to and just find out what that OID again is for that tickets table. So it's bookings.tickets. $49329. And if we edit it, 49329, we can see that that's really encrypted now, and we can't really read any of the any of the sensitive data like we could before. If we let's just connect to the database again. And I'll just copy that same query and execute it. Oops. Well, we did execute it twice before, so I'll put timing on and then execute again. It's still got to do that. Whoops. Still got to do the decryption. And you can see it's 302 milliseconds. I think it was about 230 or 240 milliseconds before. So a very minimal overhead. And the longer queries you do, the less impact it has. Now, so minimal overhead. And it's very flexible, as I say, where you can actually move even within. We've got the whole database sitting in the encrypted table space, but that database could actually be done in such a way that we move individual tables into an encrypted table space, and other tables that are part of that database could be in an unencrypted table space. So the table spaces are really just for physically or organization of the physical files, and don't have that bigger impact on the the logical database itself. Okay, that's Transparent Data Encryption. Thanks very much if you watched all the way through the video, and we might see you in one of the other videos in the near future. Thanks.